Hey, this is Lyle Dodge. We're back with Azure in the Enterprise. Today I have with me Fernando. Hey, Fernando, how are you?
Good, Lyle. Thank you for the invite for this Azure for Enterprise. How are you doing?
Good. Yourself? Oh,
Fine,
good.
everything
Obviously.
excellent.
So today we're going to kind of go through, you guys, you and the team have gone through a recent customer, and you're going to talk to us a bit about AKS and hybrid networking. So I know this is a fairly common pattern among customers. And I think, if you want to talk a few seconds about your customer, then we'll kind of go right into drawing.
Sure. So thank you for the introduction. So yeah, I work with most customers using cloud native technologies, and they are all wanting to use Kubernetes, right? They want to do microservices architecture, but they also have some services that are running on their on-premise network, and they want to access those services, which the business running, right? So in this case, we're going to talk about how to plan your network, because there are multiple layers here. There's your on-premise network. Then there is the network inside Azure, the SDN in Azure. And also there is the network that it's used inside Kubernetes in the containers, right? So you have to do a very nice planification for everything to work correctly. And this is what we're going to talk a little bit in this session. So maybe we start here. So Here we have a basic diagram. This is a basic network that it's used in the on-premise world, right? So you have your internet connection, then you have your firewall. In this case, some of those firewalls are Cisco ASA. It's very common. Then you will have your DMZ, right? Where you will be hosting some web services, some email services, some web page, and some services that you want to expose to the internet, filter through your firewall. And then sometimes you have another firewall that is going to give access to your databases or your legacy systems or other storage systems that you want to use, right? So this is very common in the enterprise. They have their on-premise networks, and they have this kind of components, right? It's a very common thing, okay? So now we're going to move a little bit to the right here, and we're going to talk a little bit about the Azure networking, right? So I'm going to talk about this. So in the case of Azure, if you haven't worked before with Azure, we have our own SDN. This means software-defined networks, in which you can create multiple topologies. You can create what we call virtual networks. Then you can create subnets. And then we have many networking components like load balancers. We have application gateways, load balancer for HTTP, HTTPS, and we have another for DNS, which is traffic manager, and also Azure Front Door, right? So we're going to talk a little bit about this. So the first thing that you have in Azure, of course, is that you have the virtual networks, right? So I'm going to try to showcase this. So here you have what we call a VNet, which is a virtual network inside Azure. And here you can specify any address space that you want. So we're going to take, for example, 11.0.0 and a 24 mask, which is going to allow us to have 256 hosts, right? So this is the first SDN component inside Azure, right? The virtual networks. You can create as many as you want. The only thing is that the address space cannot overlap, right? So that's the one thing you have to be careful. And also, if you plan to connect this virtual network in Azure to your on-premise network, you also have to be aware that the address space of the virtual network do not overlaps with the address space here in the on-premise network, right? So we're going to put here another one, let's say 20, something like this, okay? So here, now that we're working inside Azure, this is fairly easy to create, right? We can create another component that it's called a subnet, okay? So in here, we could say we are going to create a subnet 1, and we're going to have a 25 mask, okay? So here we're going to have 128 hosts. And here we could have another subnet, okay? Say subnet 2, which is going to be mask 25, and also 128 hosts, okay? So in here, for example, we could use the subnet number 2 to put some workloads, right? So I could put here some, for example, virtual machines, let's say. And this could be like any workload, right? You could have some SAP machines, you can have some different workloads that you can run inside this VNet, right? But the standard, if you want to connect this virtual network to Azure, then you have to have in the first subnet, you need to have a gateway. Okay, this will be our gateway subnet, and in here we're going to create a remote gateway. Okay, so and through this remote gateway, we can connect to the on-premise world. Okay, so here I'm going to have a connection. And this could be a VPN, a site-to-site VPN, okay? This goes through the internet with encrypted traffic, right? Or this could be, for example, it could be an express route, which is going to have a quality of service, a guaranteed bandwidth that we can use to connect from the on-premise world to the Azure networking, right? So this will be the basic things, right? We could have some workloads here running inside Azure, and they're going to be able to connect to the on-premise world. But we need for the firewalls in the on-premise world to allow this communication, okay? So this is the very basic hybrid connections that we can do on Azure, which is the VPN express route, okay? But then the interesting part in the Azure networking is that we have some very good practices that we recommend to the enterprise customers to use. And in this case, the interesting part here is that, for example, if you take this virtual network, the VNet that we have there, this VNet with the characteristics that we have, with the settings that we have set up, they can only have 128 hosts per subnet, okay? But let's say that we want to run Kubernetes here. We're going to need more than 128 hosts to run a large cluster, okay? So what we have to do here, if you can go a little bit to the right, we're going to keep drawing there, is that we need to do something that scales a little bit better. And we don't want to recreate the virtual network. We don't want to recreate the VPN site-to-site link or the express route link. We want to use it, right? So the interesting thing in Azure is that we can create another VNet. Let's say here, create another VNet. Okay, and we're going to say this is the VNet 2. Okay. And we're going to give it another address space. And we're going to give it a little bit more of hosts. Okay, so we're going to say mask 20. Okay, so this is going to allow more hosts. And in here, we're going to create a subnet. Okay. And inside here, we're going to run our Kubernetes cluster. AKS, okay? It's going to do a very small drawing here. Multiple machines, okay? Multiple nodes, okay? So this is going to be my Kubernetes cluster, okay? And this Kubernetes cluster, I want to use the same link that I had configured in the first VNet. Now I want to reach the on-premise world, right? So the interesting part here is that we can create another link between virtual networks inside Azure that it's called a network peering. Okay, so you can create another link here. And this will be called a network peering. Okay, so you can do this in Azure and you can link to virtual networks in different regions inside Azure, and they are going to be able to reach each other. Okay. And another interesting thing is that when you're creating this network peering, you can say, hey, I want to use the remote gateway in the first virtual network to reach the on-premise world, okay? So you can use this remote gateway to go to the on-premise world. You have to create it again in the second virtual network, okay? And this is a topology inside Azure that we call the hub spoke, okay? So we have here, this will be the hub, and this will be the spoke number 1, okay? So this VNet is going to have the spoke number 1 is going to have the right addresses for the Kubernetes cluster to scale, to create the containers that we want in the nodes that we want, right? So this is going to be the right size for this Kubernetes cluster, okay? But then we can have more Kubernetes clusters. We can have another workloads that we want to run. So the interesting part of this is that we can scale it. So we could create another virtual network, say VNet 3, and I can have another workload here inside. So I could have like Hadoop, something like that. Let's say here. Another workload, so we can have another workload here. And the interesting part is that I can do another peering here, okay? So I could have another peering. And I could do this up to 50 peerings, okay? So we could do this up to 50, okay? And if we reach 50, then we could use the spokes as hubs, and they will have another 50 peerings, okay? And we could extend this, okay, to use the same network link.
So what do customers typically put in the hub? I mean, is that outside of your gateway, your ExpressArt connection back, what's fairly common for customers to put in that hub? Is that where they would put in, virtual firewalls, maybe some common data stores? What do you see that's common that goes in the hub subscription?
Yeah, that's a very good question. So since this is the hub is going to have all the traffic driven to the on-premise world, it's very good practice to have here a firewall, okay? So here in the gateway subnet, you can have a firewall also to control it here. So we have the Azure Firewall Service, but there are other firewalls, right? You can use, there's Barracuda firewalls inside the marketplace in Azure that you can put inside there, or your own custom firewall, right? You just lift a VM and you install your own custom firewall. And the other thing that is very common to put here, in this case, for example, we can have a DNS server. And this is very, very common, okay? Because, this is very important because in the hub, you can reach the on-premise networks, and also you can reach all the other networks that are going to be peered, right? So probably some microservices or some containers inside Kubernetes, they need to solve the addresses of the on-premise world, okay? So it's very important to have a DNS server that knows the on-premise addresses, that can solve those addresses to IPs. So this is very important, and this is very common also. The DNS server, firewall, and if there's another workload that the on-premise world and the Azure world need to access something, this is a very good place to put these things, right? So, but you should not be putting like the Kubernetes inside the hub, because then you're probably going to run out of IPs if you did not plan correctly, okay? So this is very common things, the firewall and the DNS servers to put inside this hub virtual network, okay?
Yeah.
So with this, we have the on-premise networks, we have the Azure networking. Now we're going to talk a little bit about the Kubernetes networking, okay? Which is also another layer that we have to take care. So this, we're going to do it, let's see, below the Azure networking. Okay, so we're going to draw a little bit there. Okay, so this is another very important aspect that you have to be aware. Okay. So the first thing is that Kubernetes cluster, in the case of AKS, it contains multiple nodes. In the case you create multiple nodes cluster, right? So one of the basic units of the Kubernetes cluster, of course, is the nodes that are running there. Okay, so we're going to start right there. Okay, so let's say we have, let me draw here. Let me try this ruler. Say we have a node, right? So we're going to have a Kubernetes cluster node. Okay. To delete it. Okay. So this will be a node, okay, of the Kubernetes cluster. So the basic thing that we have to know is that every node inside the Kubernetes cluster is going to have a network interface, right? And in this case, we're going to talk about Linux nodes. And this is going to be, normally it is called ETH0, okay? And this is going to have an IP. In the case of AKS, of the VNet, right? Let's say we're using the VNet here that we talk about, will be at 12. Okay, so this is the network interface, right? And it's going to have an IP of the virtual network in Azure, okay? So then we have another component here that is going to do some network address translation. Normally, if we have services that we're running inside the cluster, it's going to translate the address of the service to the address of a pod, and this is probably going to be IP tables. Okay. Then we have another address space, which is very important, which is called the bridge, the Docker bridge. Okay. So we have an address space here. This Docker bridge also has another address space. I think by default is something like this. Remember the mask, but let's say it is something like this. Okay. And then we're going to go to the containers inside Kubernetes, right? So we're going to have, let's say, if we have two pods, we're going to have something that we call here the pod network namespace. Network namespace. Let's put here. This will be pod number 1, pod number 2. Okay. Then we're going to have some virtual addresses for each pod. Address 0, a virtual address for the second one. Okay. And then the pods are going to have multiple containers. Yeah. Let's see, we're going to have multiple containers here. But they are going to be seeing just one interface, which is going to be ETH0. Okay. So this is the network inside Kubernetes, right? There are other layers here that take place. So the address space of the node, the address space of the Docker bridge, and also the logical address space that Kubernetes gives to the services. So to the services, let's say we have another one. Normally something like this. We can change this when we create a Kubernetes cluster. So we can decide what spaces to use, okay? So what is very important to know here? So we have 3 address spaces here, and these 3 address spaces, they don't have to overlap also. So this is very important because, you know, we have an address space for the on-premise network. We have an address space for the virtual network inside Azure. And then we have these address spaces for the Docker bridge and inside Kubernetes. Okay, so all these address spaces, yeah, I'm going to highlight them. See with color red. Yes, and this one. And then we have the one in the on-premise world. Yeah. This is the network planification that you have to do, okay? So, and also the hub. Yeah, the hub and the spoke, okay? So this is why it is important to understand these concepts before deploying a Kubernetes cluster for a hybrid connection, because otherwise you could have a lot of issues. So I had a customer, for example, in which we deploy everything, the Kubernetes cluster, we deploy the hub, the spoke, we open the firewall for the traffic of the spoke, and then there was no communication. Then we find out that the address space of the on-premise network was the same as the address space of the Docker bridge. Okay, so this was confusing for Kubernetes because he could not resolve traffic because there was an overlap of address spaces. Okay, so this is very important, and you have to have a good planification around this. Okay, and then the last thing we're going to talk here in the Kubernetes networking, it's a Kubernetes inside Azure. Okay, so with Kubernetes inside Azure, we have two options. We have the first one, we can choose the Kubernetes networking plugin, and we have two choices. We have one that is called KubeNet, and one that is called Azure CNI. Okay. So this is very important. In the case of KubeNet, if you choose this as networking plugin for the containers, we're going to have for the nodes, we're going to have an IP address of the VNet. Okay. These have some advantages. For example, if a customer, they have created a virtual network for him and the customer cannot recreate a virtual network, let's say you just have like 120 IP addresses available, that it's very low. So if you use this, your cluster can scale to 120 nodes, okay? Because only the nodes are going to take an IP address from the VNet, okay? The bots are going to take a logical address. Of course, you're going to have a lot of network address translation, going on, and this could create a little bit of CPU overhead in your cluster. Okay. So this is the first option. If you have a virtual network inside Azure, let's suppose that the networking team, you cannot control, you cannot decide how many IPs you're going to have. And let's suppose that they create a spoke for you, and that spoke only has 128 IPs. So you cannot scale more than that. So then KubeNet is going to be very useful for that because you have very low number of IPs. But the other one is the actual one that we recommend for production, because you're going to have more features like network policies inside AKS, and it's going to be more secure. Okay, so in the Azure CNI world, both the nodes and the bots are going to take the IP addresses from the VNet. Okay. And this is not going to have too much network address translation, okay? So this is going to allow you to have network policies, which is a very important feature inside Kubernetes, okay? So once you know that, this is very important because also, let's say we have a formula for the number of IPs that you're going to use. So let's say the number of nodes plus 1, okay, times the number of pods. You are going to run, okay? And this is going to give you the number of IP addresses, okay? So let's suppose we're going to have a, let's say 50. So 50 plus 1 times the number of pods per node, let's say 30. This is going to be 51 times 30. And this is going to be, see if my math is right, 50, yeah, 1,530 IP addresses you're going to need for this cluster, okay? For a 50 nodes cluster, okay? So this is very important. And finally, once you have all this planification around networking, there's another very important thing that you have to know. The DNS server, which we mentioned here, this is very, very important, okay? Because if you want to reach the on-premise services from the Kubernetes cluster, then you need someone to solve those DNS names, okay? So this is very important to have it rightly configured in the hub VNet. Be able to create, you can also create private clusters inside Kubernetes using AKS, private clusters. You're going to need a little bit more of configuration if you want to use private clusters. The other thing that you have to know is that you're going to need to create in the spoke VNet. The most important thing, you're going to need to create a jump box, okay? And this jump box, you need to install kubectl and all the tools to manage your cluster. And from this jump box, you're going to do RDP from the administrator machine or the developers, the one who's going to manage your cluster. See operate, we're going to put operations here. And that's the way you're going to manage your Kubernetes cluster if you choose to use private clusters, right? You need to add a jump box there, okay? So basically, this is the main things that you need to know about networking if you want to deploy a Kubernetes cluster complete inside your connecting to your hybrid, your on-prem data centers, your on-prem services, okay? So this is the basic things you have to know. And of course, we have a better diagram for this. If you want to take a look, I'm gonna copy and paste this. Let's see. For this, and we're going to put it here. Oops. And paste it here. Okay, we have it. And a final diagram for this will look something like this. There you go. So if you scroll there, yeah, I'm going to just paste it 2 times. I'm going to delete this one, and we're going to add here to enlarge it. There you go. So this will be like a complete diagram if you want to use a private cluster, okay? So this has everything that we have been talking about, the on-premise network, the hub spoke topology, the DNS servers that we need to create. And this is some extra information about private clusters that you need to create also something called DNS zone. So this will be like the final diagram if you want to do a private cluster using AKS connected to a hybrid connection to your on-premise. And also, if you want to have all this information, in a very easy way to follow up, if you want to do this yourself, then we have what we call the AKS checklist, which is going to provide all this information for you in a very simple way, so you can check all the things that you have to do. I don't know if you could share that in your screen, Lyle, the AKS checklist. Just, in a Bing search, I think it will be one of the top results.
Yeah, let me bring that up. If you know the URL off the top of your head, I can also type that in. AKS checklist.
Yeah, there you go. So this is something that we have been working on with some other GBVs colleagues from mine, and we have it in English, French, and Spanish. We also have it in Portuguese coming. So for example, you could create your project name there, for example, your bank project, Then we have categories of the most important things that you have to do. Yeah, you can do that. You can go to network. You can click there, network. There you go. And you can see all the things that you have to do, right? So if you go to the network category, you're going to see mainly all the things that I've been talking about, right? So if you go down, a little bit down, you can see choose the appropriate network model. This is the KubeNet thing or Azure CNI, control the traffic, the HubSpot thing. Everything is going to be there. Plan the IP address carefully, which is what we have been talking about. The address spaces don't have to overlap. So everything, you're going to find it there. And also, if you click to the right, the arrow, actually that is clickable. There's a small arrow pointing, yeah, and you can see all the documentation there. So in all the languages that we have. So
Awesome.
here you can check all this information that we have been talking about, and I hope it's useful for you. And please try to plan your networking very carefully, and we hope you have success with AKS with your on-premise networks.
Awesome. I think we'll definitely make sure we put it's www.the-aks-checklist.com. So we'll definitely have that out there for everyone.
Awesome.
Thanks, Fernando.
Cool. See you, Lyle.
All right. Take care.